So hi everyone. In this problem, basically we have three tasks. Uh, in first task, we have to initialize our graph. We need to think of a particular data structure in which we will store our graph. And in the second task, we will add edges to our graph. And third, which is the main task of this problem, we have to find the shortest distance between any given two nodes. So since it is a weighted graph, so uh, I want to keep my graph in a form like that. I map each node to the node to which it is directly connecting, and along with that I have to store the weight also. So for that I can use pairs. So basically I can use pair in which first value will be the node with which I am connecting this current node, and the second value uh, will be the uh, will be the weight of that edge, right? And I want vector of such pairs. I want vector of such pairs. So I'm preparing an adjacency list. So this will be my adjacency list, right? So but there can be many such rows in my vector. It's like that. I'm mapping, since we have vertices from 0 to n minus 1 only, right? So for node 0 I have a list, right? And for node 1 then also I will have a list, and in that list I will have tuples. I will have tuples, or I can say I will have pairs, and in those pairs first value will be what, the node with which this 0 node is connecting, and the second value will be the cost. So I am denoting it with w, or we can say weight, with which 0 is connecting to v. So there again v dash, which is connected to with weight w dash. Similarly for index 2, for node 2 we will have a list, right? So how many nodes we have in our graph? So if we see the um, constraints, so here we can see that total, the maximum possible value of n is 100, right? So for to keep us in a safe zone, let's keep the size of our adjacency list to 101. So it will cover all the adjacency, all the list that we want in our graph. So for at each index we have a vector of pairs, right? And let's create another variable which will tell how many vertices are present in my graph. So I'll initialize this v with the n. So here we have our constructor graph. So here I'll get edges. I'll just put these edges in my adjacency list, and that will create my graph object. On that graph object I will apply this add edge and shortest path function. So how will we do, how to code this constructor of graph? First of all, we will loop through each edge. So I will use for each loop here. So vector of int. So I'm using for each loop. I'll get for each edge in my edges. So I'm looping through all of my edges. So basically this edges variable is a vector, and in this vector we have another vector which is my edge. So this is the vector of edges, and each such vector in my edges is a vector, and that is also a edge. So in this edge vector, vertex 1, let's call it u, I can find it at 0 index, and the vertex second second vertex with which this node is directly connecting, that I can find by edge 1, and the weight by which this u and v are connected, that we can get by edge 2 at index 2, right? So I want to put this u to v connection with weight w in my adjacency list. For that, I'll just go to index u and I push this pair of what, the node v and the cost w, right? This way I'll create the graph uh, from the given edges. And one more thing, I want to keep track of how many vertices are there in my graph. For that, I'll just initialize v with n. So the one job is done. Now we have a graph. We have constructed our graph. This was easy. And second task, add edge. This is more easier than the previous one. So in that, we will just have to find out the vertices again. To get the u and v, we'll do edge 0 to get the first node, and to get the second node, we'll just do edge 1, and to get the weight with which they are connected, we have to do edge 2. And now just make a connection between those two edges, go to at index u and place a pair of v comma w there. V comma w there. That's it. So this is how we can add new edges. And also it is mentioned here that it is guaranteed that there is no edge between two nodes before adding this one. So this gives us that we are not adding redundant edges. We are always adding a unique edge, so there is no chance of duplicacy of edges. So we are safe in that. So we don't have to handle that case separately. Now third task, which is the most important task here, we have to find shortest path between any two given nodes. And for that, we will use Dijkstra algorithm. We will use Dijkstra's algorithm. So let us know how Dijkstra works. So basically in Dijkstra, first of all, we'll loop through all the vertices. So we'll have a for loop, or we can use a while loop, whatever we want. But there is some loop. So let me first write a loop here. So we have a loop, and this loop will loop through all the vertices. So we'll loop through vertices. So we have vertices from 0 to n minus 1. So we'll loop through all the vertices. And in each single iteration of my loop, I will finalize one node. So point to be noted here is that in each iteration we will finalize one node. So how many iterations we need to get the distance of one node to all the other nodes? That will be n, right? So n number of iterations we require to do in order to find the minimum distance, or we can say optimal distance or minimum distance to that node, right? Now, first of all, we will create two arrays. One is distance array, which will be of size v, and one is final array, which will be of size v. And this distance array, of course, it will have type int, and final will give it a type bool. So this final will keep track of how many which vertex is finalized. So if final I is equals to true, then that means that ith vertex is finalized, and we don't have to work on that node further. Distance v will keep the track of optimal distance that we have calculated so far from source node to till this node, right? So distance I, distance of I means source to I distance. So what will be the, let's say my source node is node 1. So here we have uh, node 1 source and node 2 is a destination node. So what will be the distance of source to source? So if I put source here, that means we are finding source to source distance. So that will be obviously 0 because we don't have to travel any edge for that. We are already there. So distance between source to source is 0, right? So this is our starting point, and also we will need a priority queue. We need a priority queue. This priority queue is our min heap, or we can say minimum priority min heap based priority queue, which will give us the minimum distance node presented currently present in the priority queue currently. So initially I will initialize the distance of all node with int max, that is infinity distance, right? Except the source node. Only the source node have minimum distance, and all the other nodes will have a distance of infinity from that source, right? And initially find all the nodes are finalized to false, so they are not finalized, so it will keep the value false. So when I loop through this priority queue, I will pop my priority queue and I'll get the current node which is having minimum distance, and obviously in the first iteration I'll get the source node only. I'll get a u node and I will finalize this node. And that will become true. After that I will iterate through neighbors of u. So I'll iterate through adjacency list of u. So all the nodes which are directly connected to u, I will traverse to those nodes, and I will relax the edge connected to those nodes. So this is my u node, and there can be many other nodes that are connected to this node directly. Let's say v1, v2, and v3, and this is weight w1, w2, and w3. So initially they are having infinity weight, right? But let's say this v1 has also traversed by some other node. Let's say u dash is also connected to this v1, and that traversed, this node is already visited through this node. So this will have some other value, some value less than infinity. That can be anything, right? So for that we will just and that distance is stored in my distance array. So when we iterate in this, first of all I'll check if this v, which is the neighbor of this u, is finalized or not. If it is not finalized, if v is not finalized, it is equals to false, then I will consider this node. Otherwise I will not consider it, right? So I will relax this edge. So distance of v will become minimum of current distance of v plus comma the distance of u plus this weight connecting w1. Whatever is the minimum will get stored to distance, and I'll also push this this v in the priority queue. So by doing that, in each iteration I'm getting the current node which is having at least distance, and in the end I will have the distance from source to every other node. So let us code it to get the better clarity in that. So basically what we are doing, we have one distance array which is of size v, because for all it will keep distance for all vertices, it will keep distance of all vertices from source, and we have bool final which tell us whether the vertex is finalized or not. Right, so let's initialize it. Let's fill the distance with the infinity, so distance of dist plus v, let's fill it with int max, and let's fill this final bool variable with false. Right, now let's make this node 1 as our source node. So what we know that distance of source to source is always 0, so let's keep distance node 1 as 0. We need one more thing, that is priority queue. And that priority queue will keep pairs in which first pair will be distance, because by default priority queue get ordered by first element, so in the first element will be distance and second element will be the node whose distance we are getting from the priority queue. So this priority queue will be of type pair, and to make it a min heap, we have to provide a vector of pair and also a greater of pair. And so that's that. This is the syntax of making our min heap priority queue, right? So this is our min heap, which is of pairs. This is vector of pairs, and this is greater. So this greater is used to make it like that we will get minimum value at the top, and the each time we'll get minimum value that is present in the current priority queue. So we'll loop through this priority queue while it is not empty, right? But first of all, we will have to push my source node in this priority queue. So I'll put my source node with distance 0, and what is the node? It's node 1, right? So I have pushed node 1 in my priority queue. Now I will iterate in a priority queue. So let's pop it, and we know that at the top we will have a node which is currently having a minimum distance, and we will finalize that. So the vertex corresponding to that node will be the cost of that node will be pq dot top dot first, right? In the pair, first value is the cost, or we can say distance or weight, right? And the node u is at the second value in my priority queue, so I'll get it by pq dot top second, right? Now if this node u, since we will finalize this node, see, we will finalize this node u, right? So if this node u is equal to destination node, so if this we are already at destination, so we'll check a destination, and we have to simply return this cost. that we got, uh, which this cost is saying that cost of this node 2 is this much, so I'll return that cost. But if that is not true, we will check if final u is already true or not. If it is already true, then we will not consider it, but before that we have to pop our priority queue so that we will not get the same element in the next iteration. We will get different element. So if this u is already processed, if it is already finalized, then we will not process it and we will continue, right? Otherwise, if it is not finalized, we will finalize it right now. So final u equals to true. Now I will traverse all the neighboring nodes of u. So for that, I'll again use for each loop, and I will traverse in the adjacency list of u. And in the adjacency list of u, we have a vector of pair, right? So adju will have is a vector, and in that vector we have pairs. We have pair, and let's call it an edge from u to v. So the first value of this edge is let's say it is v. So edge 0 is v, and second value is my cost, edge 1, right? So we are connecting each u with v and w. So first is v, we will go to v, we call w, right? So let's relax the distance of this node. So distance of this distance array is keeping the distance of each node, right? So let's see if distance v is minimum, or if distance v is minimum, or the distance we are getting from this finalized node, distance of u plus w, right? Because u is connecting to v via this edge having weight w. So if distance u plus w is minimum than the distance v, then that will get updated to distance v. That will be the new distance if it's a minimum distance. Now I will push this new node so that it can be considered to be finalized, so that it can be finalized in the later iterations. So I will place this distance v and with my node v, right? But here's the catch. If this I will do this only when the v is not finalized, because if it is finalized, then we don't have to worry about that node, right? We have to only worry about that node when it is not finalized. If those neighboring, because we may encounter those neighboring nodes which are already considered and finalized, so we don't want to do the iterations of that, because that will give us TLE if we do that. So if v is not finalized, if it is still false, then we will relax the edge. Here we are relaxing the edge, relaxing the distance, and here I am pushing the distance with that node, right? So this will do the job, and in the end we will just return whatever the distance I got for node 2, because that is the destination node. Also, one more case we will have to handle is that what happen if there is no path from node 1 to node 2. In that case, distance of node 2 will remain int max, that will remain infinity. So in that case we have to return -1. So if distance of node 2 is is still infinity, that means there is no path from node 1 to node 2, then we have to return -1, else we will return the node distance node 2. So I hope this will work. Got an error. So line number 3, I did a spelling mistake here. Line number 42. Okay, so since it is a pair, so I thought it was an array. I have to do edge dot first, then edge dot second. Now it's accepted. So we are done with this problem.